Black holes. Getting too close to a black hole is like waking up inside a horror movie, except the killer isn't hiding behind a door. The killer drags you against your will, and there's nothing you can do about it. The killer is the black hole, and no matter how much you try to escape or scream into the void, you can't escape its grasp. And the thing is, you're getting dragged toward an object that doesn't even look like it's there. Just a patch of space that eats light, swallows time, and stretches anything that gets close into subatomic spaghetti. And like every good horror villain, it doesn't run. It waits, because once you're caught in its gravity, it knows exactly how this ends. This charming little effect is called spaghettification. It's what happens when the gravity on the part of your body closest to the black hole is so much stronger than the part that's farther away that your body stretches into one long tragic noodle. Stephen Hawking himself gave us the term. Thanks, Steve. But that's not the only way black holes ruin your day. For bigger prey, like entire stars, the forces involved can actually flatten matter instead of stretching it. Scientists call this pancake detonation. Yep. Space has a setting for both spaghetti and pancakes, and neither comes with syrup. Stars get squeezed like overstuffed stress balls, flatten into disks, and then, just for vibes, detonate into a burst of thermonuclear rage. Now, if you were watching all this from a safe distance, let's say a couple 100 million light-years away, you'd see some real-time weirdness. Thanks to gravitational time dilation, anything falling into a black hole appears to slow down forever. That star just got too close. From your perspective, it starts to stretch, fade, and freeze at the edge of the black hole, like some cursed GIF that won't load. It's the ultimate cosmic cliffhanger. What about all that stuff getting sucked in? Where does it go? Honestly, no one knows. It could be obliterated, it could be compressed into quantum nothingness, or maybe, just maybe, it slips through a wormhole and lands in another universe where we are the advanced species and gravity is optional. Probably not, but who knows? Also, just to be clear, black holes aren't rare. There are millions in our galaxy alone. Some the size of cities, some the size of entire solar systems, and one's just hanging out in the middle of the Milky Way, spinning silently like a cosmic blender waiting to hit puree. Thankfully, Earth isn't on the menu. Yet. So next time you feel like your job sucks or life's pulling you apart, remember, at least it's not literally tearing you into spaghetti and flattening your atoms while suspending your existence in a timeless void. Magnetars. If black holes are like horror movie killers dragging you into the basement, magnetars are the ones that kill you without even stepping inside the house. You don't hear them. You don't see them. They just flip a switch, and your atoms stop playing by the rules. Magnetars are what you get when the universe decides neutron stars, already absurdly dense, terrifying stellar corpses, just aren't intense enough. Picture something the size of a city with more mass than the sun, spinning like a blender, and wrapped in a magnetic field a quadrillion times stronger than Earth's. That's a nightmare you don't want to be caught in. If you ever get caught in the range of one, your spaceship would go crazy, your screens would go static, your muscles would stop listening to your brain, and your thoughts would flicker like dying fluorescent bulbs. It's a magnetic field so absurdly strong, it doesn't just fry electronics, it shreds atomic structure. That means your body, your blood, your bones, your brain, all the atoms that make you, suddenly get yanked into unfamiliar shapes. Electrons snap out of their neat orbits. Chemical bonds go poof. You don't burn. You don't explode. You unravel, like a sweater caught in a black hole zipper. And no, you don't have to be standing on the surface of one. You could be hundreds of thousands of miles away and still get shredded on a subatomic level. That's like being across the country from a microwave and still getting cooked. Let's say you survive that somehow. You won't, but let's pretend. Magnetars aren't done. They throw giant flares. These are immense eruptions of gamma rays and X-rays when their crusts crack during what scientists call starquakes. Imagine an earthquake, but on a neutron star's surface, releasing more energy in a tenth of a second than the sun will emit in 100,000 years. One such burst actually hit Earth back in 2004. From 50,000 light-years away, it temporarily messed with our upper atmosphere. If it had been any closer, we wouldn't be talking right now. We'd be vapor. Atmospheric vapor. Now imagine this stellar horror decides to merge with something, say another magnetar, or worse, a black hole. Scientists theorize that kind of smash-up would not only release catastrophic levels of radiation, but could twist the very fabric of space-time into an unsolvable math problem. If you like your physics broken and your cosmos on fire, this is how we get it. Black holes pull you in. Magnetars don't even touch you. They just rewrite you from across the room. No screams, no chase scene, just the universe pressing a button and turning you into cosmic confetti. And hey, if you're still holding your atoms together, that deserves a like. Maybe even a subscribe, because trust me, it only gets worse from here. Rogue planets. If black holes are the stalkers and magnetars are the assassins, rogue planets are the strangers who wander into your quiet neighborhood with no plans, no license plate, and nothing to lose. They're not hunting you, they're not aiming at you, but if they bump into you, you're done. Rogue planets, also called free-floating planets, are basically cosmic orphans. They don't orbit any star, they don't belong to any system. They just drift through interstellar space like a drunk god forgot where it parked them. Now picture this. You're on Earth, living your life, scrolling memes, arguing with strangers on the internet. Meanwhile, across the galaxy, a rogue planet is silently drifting towards your solar system, like a cosmic wrecking ball with zero regard for planetary property lines. It wasn't always alone. Maybe it got ejected from its home system in some violent gravitational game of musical chairs. Maybe it formed on its own, a failed star that never quite lit up. Either way, now it's just out there, wandering. A cold, dark wanderer the size of Jupiter, or maybe even Earth. And it's not glowing or radiating like a star. It's just a frozen wreck with enough mass to ruin everything it touches. And that's the thing. Rogue planets aren't trying to kill you, but if one decides to swing by your system, it could casually wreck everything. If it gets too close to your sun, it might tweak the orbits of the planets. You won't notice at first. Until months later, Earth's path is off by 0.5%, and winters last 30 years. Or the moon gets pulled closer and starts stirring the oceans like a ladle. Tides flood cities, climates shift, ecosystems die. You get the idea. And if it really gets too close, impact. Total annihilation. Rogue planets don't need speed. They bring mass. If one collided with Earth at full throttle, the result wouldn't be just extinction. It would be obliteration. Mountains would liquefy, oceans would vaporize, the Earth's crust would peel like tin foil in a microwave. Don't panic. The good news is space is huge, like stupidly huge. The odds of a rogue planet slamming into Earth are lower than winning the lottery or being struck by lightning on your birthday. Still, astronomers believe there could be trillions of these things floating around. Yes, trillions. That's a lot of bullets in the cosmic chamber, even if the gun's pointed the other way. And the creepy part? We barely see them. They don't shine, they don't twinkle, they're stealth planets. One could be cruising silently past us right now, completely invisible without the right instruments. We only spot them when they pass in front of something else and warp the background light, like an interstellar jump scare. Oh, and here's the twisted part. Not all rogue planets are dead. Some of them might actually harbor life. If a rogue planet has enough internal heat, say from radioactive decay or leftover formation energy, it might have a subsurface ocean, a thick atmosphere, or even habitable moons. The scariest monsters in the universe aren't actually the ones that chase you. They're the ones that don't even know you're there. Supernovae. Imagine waking up one morning and the sky's off. Not red, not dark, just wrong. It's glowing like a welding torch behind a fogged window. Birds don't sing, the air feels sharp. Somewhere far, far away, a star has died, and its death scream is coming for you. A supernova isn't just a star ending its life. It's a cosmic-level tantrum where a star explodes with such force that it releases more energy in a few seconds than our sun will emit in its entire 10 billion-year lifespan. These explosions are nature's flashbangs, bursting with X-rays, gamma rays, and cosmic rays that don't care about your atmosphere or your evolutionary progress. If one happens close enough, say within 25 light years, it won't come with fire or debris. It'll come with radiation so intense it could strip Earth's ozone layer like peeling skin off an apple. No ozone layer? Say goodbye to anything that isn't living in the deep ocean. UV radiation from the sun would hit the surface unfiltered, burning ecosystems like a blowtorch to a butterfly. Crops would fail, skin cancers would spike, food chains would collapse like a drunk Jenga tower. But wait, there's more. That radiation burst is just the first punch. What comes next are cosmic rays. These are charged particles moving at nearly light speed, slamming into the atmosphere and slicing through cells and DNA like invisible bullets. You wouldn't feel them, but your body would. Think of it like trying to survive inside a microwave filled with razor blades. Not ideal. And this isn't theoretical. There's growing evidence that a supernova might have triggered a mass extinction on Earth around 2.5 million years ago. Fossil records show a drop in ocean life, while ancient seabeds reveal spikes in radioactive isotopes, tracers left behind like galactic fingerprints. We may have already taken a glancing hit. Different types of supernovae have different personalities. Some go off quietly like fading embers. Others explode like a thermonuclear middle finger. The most dangerous for us are Type 2 supernovae, the deaths of massive stars that once burned brightly but lived fast and died violently. When one of these goes off in our galactic neighborhood, it doesn't knock. It kicks in the door and rewrites your planet's biosphere. And the distance matters. At 30 light years, we might just get a light show. At 10, extinction. Not in a cool sci-fi way, in a what happened to the ozone, and why is everything dying kind of way. And there's nothing you can do. Supernovae don't sneak up quietly. They're visible across galaxies, sure, but by the time you see it light up the sky, the worst of its radiation has already passed through you. It's like getting a postcard from your nuclear blast seconds after it's already hit your house. We're lucky, though, because the closest ticking star bomb, Betelgeuse, is around 642 light-years away. When it dies, it'll be a fireworks show, not a death sentence. The Great Attractor. This one's different. No radiation, no killer flares, no cosmic spaghetti, just motion. Relentless, inevitable motion towards something we can't see, can't touch, and still don't fully understand. If this were a horror movie, the Great Attractor wouldn't be the monster. It would be the ominous music in the background. Always playing, always pulling, getting louder, closer, without ever explaining why. The Great Attractor isn't an object. It's not a star or black hole or a rogue planet waiting to pounce. It's a gravitational anomaly, a vast region of space, tens of millions of light-years across, with so much unseen mass that it's literally pulling entire galaxies toward it like some cosmic whirlpool, and we're in it. Right now, the Milky Way galaxy is being dragged along with Andromeda, the Virgo cluster, and hundreds of thousands of other galaxies at about 600 kilometers per second toward this invisible gravitational sinkhole. You can't feel it, you don't notice it, but everything around you is slowly being tugged in one direction by something we still can't fully observe. Something so possessive that it's not letting us go. Astronomers first noticed it when they realized galaxies weren't just expanding outward from the Big Bang. They were drifting off course, like ants marching across a warped trampoline. The Great Attractor isn't on a map. It's behind the zone of avoidance, a thick cloud of gas, stars, and cosmic dust that blocks our view from Earth, which means we're being pulled by something we can't even see. The region itself is centered on the Norma cluster, one of the most massive known galaxy clusters, but the Great Attractor is bigger than any single cluster. It's not just the gravity of stars and dust, it's dark matter, dark energy, and possibly something else. A gravitational ghost, a force that bends space-time without making a sound. And the most unnerving part? No one knows where we're going. There's no finish line, no giant wall waiting to stop us. Just an endless fall toward an ever-deepening pit of mass that keeps growing. Some scientists believe the pull doesn't stop at the Great Attractor, that it continues into a deeper, darker region called the Shapley Supercluster. Like you're not being dragged into a monster, but into the monster's mouth. It doesn't threaten Earth in the traditional sense. There won't be any apocalyptic collisions or planet-shattering events. Not today, not tomorrow. This isn't death by explosion, it's death by gravity, slow, quiet, and permanent. Like drifting in the ocean and realizing the tide never stops pulling you away from the shore. Maybe in a few billion years, the Milky Way will have spiraled into this gravitational abyss, stretched and shredded by tidal forces we can't predict. Maybe we'll never reach it. Maybe the expansion of the universe will outpace the pull and leave us hanging in limbo, halfway to nowhere. Or maybe it's not about us at all. Maybe we're just a loose thread being pulled into the seams of something bigger, something old, silent, and always hungry. The Great Attractor doesn't kill you. Yet. It's probably just a space dog playing with its food. It pulls you, slowly, invisibly, unstoppably, and the worst part? You'll never even know you've arrived.